So here's the first mathematical example of using the conservation of energy. A ball of mass 5 kilograms is thrown upwards with initial speed of u equals 20 meters per second. Using the conservation of mechanical energy, find firstly the maximum height of the ball and the kinetic energy when the ball attains a speed of 6 meters per second. So, using the principle of conservation of energy, I would like you to try this problem, and when you're ready, come back for the solution. So here's the solution. Initially it has a speed of 20. I should have put that the initial height is 0. And then when it has a speed, or v equals 0, that's when it's at its max, it will have a height of capital H. So I've let capital H be the max height of the ball. So here's our conservation of energy equation. So we have the mass times g times the initial height 0, plus a half mv squared, or u squared in this case, is mgh1, so capital H, plus a half mv squared, so v is 0, so that goes. So what we're left with is 1000 equals 49h, which means that the max height is 20.4 meters. You can verify this with Suvat very easily. I'll leave that as an exercise for the viewer to verify that you get the exact same answer. Secondly, at 6 meters per second, the kinetic energy is a half times 5 times 6 squared, which turns out to be 90 joules. So when it's at 6 meters per second, so roughly about, draw it in, so roughly about here, its kinetic energy will be 90 joules. Again, as another exercise, I want you to find the potential energy at that point, and you'll find something very intriguing about these two quantities.